Hello everyone, this is group 9. We are discussing hierarchical clustering. My name is Sunil and I'll be talking of the introduction. So before we define what hierarchical clustering is, we need to define what clustering is. So clustering is grouping of the available data into different sets of groups so that the data in each group is similar to every other data, and each group is different from the other groups, like they have some clear distinction. Now, hierarchical clustering is a type of clustering in which each data is like grouped into set of other data so that they form clusters, and each cluster has some nested subclusters. So this is in contrast with the partitional clustering, where each, like, we split the data into separate clusters so that there is no overlapping between them. In hierarchical clustering, we represent the clustering in a tree format where each node is a cluster and its children are subclusters, and the leaf nodes are individual data points. Now there are different types of hierarchical clustering, such as agglomerative and divisive. So in agglomerative, uh, we take two clusters and then we merge them, like, so that they are we the clusters that we select to merge are such a way that they have like closest proximity. So we need to define what proximity is between each cluster, and we repeat the process until we reach a single cluster. And when it comes to divisive clustering, we take the entire cluster, entire data, and then we split the cluster into different set of clusters, and then we select one of the cluster from that, and then we repeat the process. So in divisive method, we need to define how we select the best cluster to split. Now let's talk about the agglomerative approach. This is the algorithm for the agglomerative approach. So for that, first, if we don't already have the proximity matrix, we need to first compute it. So this depends on the type of data, and we define the proximity between every pair of clusters. Now we take two clusters so that they are close to each other, we merge them, and we repeat this process with another cluster so that at the end we only have one cluster. So here steps 3, 4, 5 are repeated until only one cluster remains. So we represent hierarchical clustering in a tree-like structure called Dendrogram. So here in Dendrogram, uh, both the clusters and the subclusters relationship is represented. So for example, here we have P2 and P3 which are closest to each other. So we first merge them, and the resulting cluster is merged with P4, and that is merged with the P1. Now this is the algorithm for the divisive approach for hierarchical clustering. So here we take the entire data and then we split that into different clusters using another clustering method such as k-means. Now we need to select one best cluster among these clusters to repeat the process. So we split that selected cluster again using the flat clustering algorithm such as k-means, and we repeat this process until there's only until the clusters remaining have only one data set in each of them.